Smith Seckman Reed's commissioning division, SSRCx, has a proven track record of getting building systems operating exactly as designed through their expertise and client-centered focus. When SSRCx performs new construction commissioning and lead commissioning, their three-phase approach gets building systems operational and functioning to their full capacity. SSRCx also performs retro commissioning by optimizing an occupied building systems to meet the occupants' and owners' needs. SSRCx is also just one of a few companies in the world licensed to provide continuous commissioning services. By optimizing HVAC system operations for existing conditions and providing ongoing monitoring of energy usage, continuous commissioning provides owners with the best performance at the best cost. SSRCx also provides building enclosure commissioning to look at moisture control, air leakage, and energy performance. SSRCx, Smith Seckman Reed's commissioning division.
Good afternoon, everyone, and thank you for joining us for the fifth installment of the CX Energy Virtual Experience. These webinars are presented by the AABC Commissioning Group, as well as the sister organizations, the Associated Air Balance Council and the Energy Management Association. I'm Sam Schwartz, and I'm a Member Engagement and Marketing Manager for ACG, AABC, and EMA. Since we were unable to meet in person this year at CX Energy, we're hoping to bring you as much of the commissioning, energy management, and testing-related education as we can through a combination of 5 webinars like this one, and as well as some additional pre-recorded sessions. In terms of continuing education credit, you will receive an email after the webinar with instructions on how to get your proof of attendance. We're going to be asking you to check into these sessions through the CX Energy app to help automate that process. Continuing the virtual experience today is Healthcare Emergency Power Supply Systems Commissioning, Clearing Communication Hurdles with your speaker, Jason Perigo of SSRCx. Thank you again, everyone, for joining us. And with that, I'm going to hand it off to Jason.
Thank you. Everybody, appreciate your attendance today and joining us. We're going to talk about healthcare emergency power systems. About 17 years ago, I was walking down a hallway of a major healthcare facility. I was working on a cath lab expansion project for that hospital. I remember walking down the hall in like most cath labs and OR suites. They're typically in the inner parts of the building. So you do your 100% artificial lighting, little to no daylighting at all. I turned the corner, walked through the set of double doors to go into the cath lab suite, and the lights flicker. The lights flickered. I stopped. I thought, that's odd. Took a couple more steps. They flickered again, and then they went off. Like any good electrician or electrical engineer, I started counting. 1, 2, 3, 4, knowing that, hey, by that magical number 10 second point, the light should come back on. The generator system should have kicked on. Light should be back on. But when I got to 10, they didn't come on. When I got to 15, they didn't come on. When I got to 20 seconds, they didn't come on. They didn't come on at all for up to 20 minutes. It was a major hospital. It was a level 1 trauma center, middle of the week, middle of the day. So they had a full OR docket on. Emergency department was packed out. ICU rooms were packed out. It was a major event for the facility. They were literally doing chest compressions and ventilation by hand on that day. That particular facility had 2 redundant utility feeds that just happened to both go down at the same time. So I remember that event. I remember what it meant for the facility, for the contractors, and for the engineers that were part of the, that supported that facility. And every time that I go to a hospital and I work on emergency healthcare power systems and facilities, I always have this in the background of, hey, why this is important. And so it helps to kind of frame our conversation today that, hey, this is really important. And when you have people's lives and you have businesses and facilities who have liability implications associated with those type of loss of power events, it's very important. So today we're going to talk about healthcare emergency power systems and clearing the commissioning and coordination hurdles. We're not going to dump into the technical details much of how we go about doing the test. We'll talk about it a little bit, but we're going to just talk about all the different coordination hurdles. How do you manage all the players, and how do you get to a successful end? So for our conversation, we're going to review 4 different facilities that we completed emergency power system testing on. So the top left there is Baptist Memorial Hospital. That's in Oxford, Mississippi. It was a full replacement facility. It's roughly 540,000 square feet, 217 bed acute care facility. It had 3 paralleled 1500 kW units, and it was connected to a common bus paralleling gear that had 13 ATSs connected to it. On your bottom left is Vanderbilt Children's Hospital, and that's in Nashville, Tennessee. It's an existing facility. It's a little over 835,000 square feet, 305 bed facility, and it's a level 1 trauma center. It had 3 parallel 1500 kW units and a common bus paralleling gear system with 16 ATSs connected. On your top right is Vanderbilt University Medical Center, also in Nashville, Tennessee. And it's an existing facility, and it's roughly 3 million square feet, 832 bed level 1 trauma center. This particular one had 5 paralleled 15 kW medium voltage gen sets, and we tested this one in 2 phases. The first phase had 42 ATSs connected, and the second phase had 63 ATSs total that were part of the test. On your bottom right is UW Hospital and Clinics, and that's in Madison, Wisconsin. It's an existing facility, roughly 1.3 million square feet, 616 bed, level 1 trauma center. It has 3 paralleled 2,500 kW medium voltage gen sets. It is a split bus configuration with 13 ATSs connected in phase 1 and approximately 40 ATSs as part of phase 2 testing. So that's going to be our baseline. What we're going to talk about is the process that we used when testing, when developing the testing and actually walking through all of the testing as we started and to finish for these particular projects. So understanding our objectives, really simple: the what, the why, and the how. We're going to attempt to define it. We're going to kind of go over a couple of common misconceptions. We'll briefly touch code requirements and the value and the life safety aspect, and then how. We're going to talk about the planning, the implementing, and the documenting. So defining an emergency power supply system, let's just briefly hit the misconceptions. An emergency power supply system is not a black site test. A lot of times when we have emergency power as part of our scope, we include emergency power supply system test and a black site test. A lot of times that gets a misconception from the owners or the contractors that they're one and the same, but they're actually not. There's 2 different tests. The EPS test is more than just a generator testing. And the EPS test includes all components of the emergency power distribution system. One thing of particular note to consider is that if the project scope includes emergency power, defining that EPSS test should be documented in the CX kickoff meeting, clearly documented to the entire team, but also it should also be included in the commissioning specifications that are hopefully part of the bid package. That way, the requirements are clearly communicated to the team when the contractors bid it, all the way through to actually implementing that particular test. So defining, we'll use the NFPA 2019 glossary of terms to define the EPSS system. So it's a complete functioning emergency power supply coupled to a system of conductors, disconnecting means, and overcurrent protective devices, transfer switches, and all the control, supervision, and support devices up to and including the load terminals of the transfer equipment needed for the system to operate as a reliable source of electric power. So in the pictures, here you can see it's the generator, it's the ATS. To your far top right there is the paralleling gear, and your conductors that are connected to the paralleling gear, another picture of some ATSs, and then on the bottom right is a SCADA screen. That is basically your control unit interface. That particular one was quite nice. It was touchscreen, so you could touch on any one of those components and bring up the system information at a glance anytime that you needed. So why commission the healthcare? Why do we do this? So there are applicable codes, your AIA guidelines, NFPA 99, NFPA 101, NFPA 110. All of those kind of set out how our emergency power supply systems should operate. And they kind of define, this is what it should be. Well, we have the operating instructions. Well, how do we verify that the system actually operates as code would tell us it should? The only way that we can do that is by testing. So verification by testing. So the applicable codes would say that we need to test. So added value. So in new construction projects, when we're talking to clients, why would I do this test? What's the value in for them? Well, when our clients get to witness this test or read the reports after we're done, it's going to help them to effectively produce their emergency preparedness plans and also develop their method of procedures when they have a power outage, when they're running prolonged on generators. And the same is true for existing facilities. In the existing facilities, it might be a little bit more beneficial because they're going to be able to look at their defined emergency preparedness plans and their method of procedures, and then they're going to be able to go back and say, hey, this didn't work. We can go back and we can redefine it now because we've actually seen the system in operation in a controlled method on what it's actually going to do. The second one kind of follows the existing facility, and it jokingly I say it's the whoops factor. In that picture that you see there, I was doing testing on a facility, and we were doing emergency power system, and I was in the paralleling gear room, and I needed to check something on the generator. And so I walked out of the paralleling gear, walked into the generator plant, and when I turned the corner to go to the generator control panel, there was this geyser of fuel oil shooting out the top of the fuel oil day tank, which is that white box there in the center of the screen. I wish that I could have gotten a picture of it actually shooting out, but this was after we hit the emergency stop button and shut the whole test down. But what had happened is somebody had came in there and worked on that day tank, and they shut all the shutoff. They hit the bypass valves, and instead of allowing the fuel to go into the day tank, they advertently pushed it back up into the vent pipe, and the fuel was just being pushed out and just spewing all over the room. What you see there is about a 6 to 8 inch housekeeping curve, and it's about halfway filled up with fuel oil. And that was roughly about 300 gallons of fuel oil that went into that generator plant at that time. Other times I've done testing on existing facilities where over time, I did one, and there was a mechanical plant, a part of the CEP. They had all their steam boilers and stuff on the emergency power system, but they didn't have all their pumps, their associated pumps they had taken it off the emergency power system and put it just on straight normal. So when we lost normal power, the pumps continued to run, and they pressurized the system, and they blew all of the pressure relief valves. And it was just a big steam sauna in the mechanical room that ended up setting off the fire alarm for the building, which was really unnerving when we were doing testing. But it allowed the facility to see that somewhere in the history of renovations, there was a wrong connection to some of their systems, and they were able to go back and reevaluate and then switch the pumps over to the emergency power supply so that they had a fully functioning steam system. So that's part of that added value of, hey, we find these things, we see these things. Your system, your facility is going to be better for what we do after this test. So the other thing is life safety. And going back to my story at the beginning, every facility will eventually experience an emergency power event that affects the facility operation, patient service, and patient care. And that means the ORs, that means your emergency department, that means the ICU, that means your imaging, your labor and delivery. All of those departments are going to be affected when you're running on emergency power. So in an interesting survey from ASHE that after Hurricane Sandy, they did a study, and they went through the East Coast hospitals there. Out of 390 healthcare facilities, 138 lost normal utility power during that event. Their loss of normal power ranged from 1 hour to 168 hours. 1 hour running on generator is a long time for a hospital if it's not designed to do that on a regular basis. But 160 hours is just an unbelievable amount of time to try to do patient care and operate a facility. So you want to make sure that the emergency power system is fully functional, robust, and reliable. So we get into, okay, how are we going to go about commissioning this? So how do we do it? So one thing to keep in mind is that the commissioning of the emergency power system, supply system, is not a sprint. You're not going to bring this to attention to your client and then say, hey, next week we want to test this. Most of the ones that I have worked on have taken months, 4 to 6 months to coordinate to get to the point where we can safely do the emergency power system test either on a brand new facility or on an existing facility. So keep in mind, it's a duration. It's something that you have to put the long haul effort into to have success in. And there's 3 parts to making it successful: planning, implementing, and documenting. So this is where we get into the meat and potatoes of what we're talking about. How do we get over these hurdles? How do we coordinate all of this? Planning, implementing, documenting are the keys. So in the planning stage, first and foremost, you want to know the OPR and the BOD, right? You want to know the owner project requirements and the basis of design. You want to get a good feel for it and be able to boil it down so that you can make sure that your client is going to be served by you to meet what their expectations are, or at the very least to define the expectations. And the second is know the emergency power system. You're gonna test it. Well, what does that system consist of? Every system is different, so you need to know it. You need to take time to look at the drawings, and if it's an existing facility, get on site, review it, talk to the maintenance electricians and the facility managers, and what kind of problems do they have? How does their system normally work? So like your generators, what's the quantity? What's the size and capacity? What's the connected load? The system settings that you that are on there, they're all going to vary and different from each other, and that is going to help to define how you write your functional performance testing. Your ATSs, what's the quantity, the size, the capacity of them? What's the connected load, the program time delays, designated priorities, load shed features? Is it open or closed transition, bypass isolation? Does it have in-phase monitoring? All of these, again, you need to be able to gather all that information in order to be able to know how you should test it and how the system is actually going to operate. So know the emergency power supply system sequence of operation. So if it's a brand new facility, the engineer of record is going to help to define this. You should be able to either request that, hey, I want the sequence of operation on how you intend the system to operate, or the vendor supplying the paralleling gear or the generator sets should be able to say, hey, this is how my system operates. And then you can take that and help to get the basis of your functional performance test written. So a typical emergency power system sequence of operations, you can either have a common bus or a split bus mode. Now, one thing to note, if you have a split bus configuration, you're going to have two tests that you have to do. So you're going to have a common bus mode, that's part of the test, and then you're going to also have to do have a test for split bus mode operation. So that's something to keep in mind. Automatic or standby mode, emergency mode, utility restoration mode, generator demand and bus optimization, load control, load sensitive load shed, and conditional load shed. All of these are different functions of the paralleling gear system. And so you might have ASCO, you might have Russ Electric, or another paralleling gear manufacturer. But and so the terminology may change on what they call how their systems operate, but they all kind of operate very similar. They have very similar functionalities to them. So develop your, once you know the OPR, once you know what you're working with, the emergency power system, what you have, and then once you understand the sequence of operation that's there, then you can start to develop your functional performance test. It's very important that you estimate your time accurately up front. When I'm writing a functional performance test, depending on how big and how complicated the system, I've had them where I've had 80 hours of time invested in writing a functional performance test. And the actual functional performance test has been 85 to 90 pages long. It's not a small document, and in order to be accurate and to make sure I capture all the details, it takes time to do that. So when you're setting out to do an emergency power supply system test, make sure that you have the time for estimated accurately so that you can be prepared to put that time in. Choose the right template. We at SSRCx, we have two different templates that we use. We have one that's an Excel type based that we can put into CX Alloy, or that we can put into Building Start. And then we also have a Word document that we produce for depending on which one is the best fit for the facility and the system that we're testing on. So make sure you have the right template for the system you're using. Include ATS schedules. These are really, really handy. They're handy when you're doing the test and when you're writing the testing script, because that's going to allow you to be able to see how each ATS is going to function and what the connected load is. But also, once you have the ATS schedule developed, it is a great tool for the facility to pass that on to them, because now they have all of their transfer switch information in one convenient document. Now, the nice thing in most situations, as the commissioning agent, I don't have to develop that ATS schedule. What I normally do is I have a blank template. I provide that to the client and to the contractors, and I say, can you get this information for me? And because it's their facility, because it's an active design, they're more fit to be able to quickly get that information and send it back to me. So all I have to do is provide a template, and then that template becomes a great resource to our clients at the end. If you can, do searchable table of contents. It helps to go through a massive document a lot faster. Color-coded system one lines. It helps, all these things right here, the organized to test and by test and steps. When you're actually doing the work and implementing the test, these make it easier to produce the final document, but also to work your way through the test. So build the team. So once you got all the above information, now you know who has to be involved. And so there's a lot of people involved when it comes to doing emergency power supply system test. Organizational charts are very useful, but you can see our list here. You got the owner's rep, facility management team, facility maintenance staff, construction managers, electrical contractors, generator vendor, ATS vendor, mechanical contractors, elevator vendors, facility IT management, facility OR department, facility imaging, and design engineer, or the code officials. And depending on the facility, you could have additional people as needed, or less people depending on the project. But definitely have to, there's a lot of people to invite and to coordinate so that they take part and that their departments and their systems are not inadvertently affected. So 7, revise the EPS functional performance test and get a team sign up. So once you have, you build the team and then you define your known impact. So you got your EPS functional testing script, you get the team together, you have a meeting where everybody reviews that functional performance test. It usually takes about 2 hours to read through a very large, lengthy one. So it's a long meeting. Everybody goes through, they talk about, they provide any feedback on it. And then you're able to define the known impact. You revise the EPS functional performance test script, and then you send it out for a review for the team again, and you have everybody sign off that, yep, we agree to test the system this way, and we've been heard, we understand what the impact is going to be, and we're willing to go forward at that point. So you have the whole team put together and marching in one direction. So how do we implement? So now that we got our functional performance test, we have our team put together, and now how do we do that? How do we define what readiness for testing looks like? So you definitely want to do that. You definitely want to define what that is to the team. So there'll be additional meetings when you say, okay, Mr. Contractor, this is what ready looks like. All the ATSs are installed. Conductors are connected and terminated. Your systems have been individually tested. Vendor startup is completed. Paralleling gear programming and startup is completed. That takes a long time. It's a complicated system to have the vendor come in and program. And so you want to make sure that those checklists are taken care of before you set dates for testing. Very important to make sure that all components are done. What you don't want to happen, what you want to try to avoid is going in and testing and then having the paralleling gear vendor or somebody say, hey, I can't fix that today. I'll have to come back and reprogram later on. If it's a brand new facility, there's a little bit more leeway with that. You can say, okay, we come back. But the understanding of the emergency power supply system test is once you test it, there's no more programming changes because you're testing the actual program. And if they come in and they change the program, you now potentially have a program that has not been proven. So the ideal is everything is done before you test, and then you actually test the finished product. And hopefully you have time built in so that as you test it, if there are issues, the team is there so that you can correct the issues as you go, so that you have a fully functioning and robust system at the end of testing. So number 2, organize the team. So get the team together. What this looks like is, if you have a large facility like the one where we had like 42 ATSs, all of those emergency transfer switches, our automatic transfer switches, they were not in one room. They were spread out over hundreds of thousands of square feet. There were multiple rooms. And, as the commissioning agent, I can't be at all locations. So how do we observe and watch these? So what we ended up doing is we put contractors, an electrical contractor and an electrical maintenance staff in each space. And to the right here, you see that picture. That's an ATS on a project. And what we did is we put tape on the face of each ATS that was going to be operated. And we've put on there, hey, it's going to be under this test and under this step is when this is going to operate, and gave the local contractor and maintenance staff, everybody had two-way radios. We communicated, and everybody clearly was communicated to on when to report back and what they should be looking at. So that took a little bit of time in organizing everybody together on what they're going to do. So coordinate with building systems, equipment, and end users. This is important too. It kind of goes in step with building the team, but as you get closer, you want to make sure that if and this goes for new building, new facilities, and existing. If your imaging department, you want to be able to communicate with the hospital imaging and IT departments and let them know, hey, we're going to be doing this testing, and you're going to see 6 outages. You're going to see 2, or whatever their systems are connected to. You want to let them know what their expected impact is going to be, so that they can then protect their systems as needed. Some imaging equipment vendors are going to come in and probably say, hey, for this day, we're going to shut this off. We're just going to shut this equipment off so that we don't get hit with all these power blips, and because we want to avoid damaging the equipment. And maybe the same for the IT department. Maybe they're going to bring in or divert the use of some of their servers and stuff to a different facility or different location while the testing's going on. But you want to give everybody a clear understanding of what they should expect before it's done. And so as you march closer, about a week to 2 days before testing, you want to have a go, no-go meeting. And as you gather the team, and the team for the go, no-go meeting is going to be everybody that's going to be there on the day of, and all the main decision makers that are going to be the players in the room. So you're going to say, hey, are we, Mr. Contractor, are we ready? Is everything done and ready to go? And then yes, and you check it off. And then, hey, is the weather going to cooperate? Do we have the load banks connected? Is everything in place? And then in that go, no-go meeting, you also talk about contingency plans. All right. Who's going to make the call if we can't test? What happens if we're in the middle of the test and there has to be an emergency surgery? And who's going to make the call for us to back out of the test? What does that back out plan look like? All of those things are kind of talked about and confirmed in the go, no-go meeting. And at the end, if everything is set to go, you say, okay, we've got our date, and now we head towards the day of testing. So the day of testing, it's going to be a long day. Most of these tests, the ones that we're using as our examples for these 4 different projects, the shortest one took 8 hours, and that was the Baptist Memorial Hospital. All of the other ones, they took the Vanderbilt Children's Hospital. It took 12 to 16 hours roughly to complete those tests. And in existing facilities, that is a nonstop test. When typically it's done over a weekend, and you have to have the facility schedule down periods. You work into the low census days with the hospital, and then you do the test. And so they're long and protracted. So protracted. How are you going to do meals? Because when you're doing the testing, it's one test after the other, and you're just running straight through it without stopping. So who's going to bring meals? Who's going to manage, breaks and things like that for people? So you have additional staff sitting in place to be able to fill in for others as they come and go, as they need to have breaks. One funny thing I can share with you is I was doing one test, and we started at, I think, 8 o'clock in the morning, and we ran until, I think, 10 o'clock the following day. I mean, it was just so long. For lunch that day, we had sub sandwiches. For dinner, we had the same place had sub sandwiches. And then for breakfast the next day, they brought sub sandwiches again. It was the same meal 3 times in a row. And I don't think anybody on the project wanted any type of sub sandwich again for quite a while. But those kind of things, take in consideration the day of testing, get lots of sleep, and let everybody know that's going to be taking part in it. It's going to be a long, grueling day of testing. So on implementing of our testing. So this is really, documenting. This is the key part. You have to keep detailed notes. When I'm doing functional performance testing, I am writing down everything. I'm the when, the what, the where, the how, and the who is always getting documented. And I'm stopping and asking, like, hey, what just happened here? Why did that happen? And I record it. And then I include that in my site visit report. That all what happened is going to be included in it, and detailed notes are very, very, very important because it helps you to define the process, but it also helps the team to be able to go back if there are issues and find out exactly what happened and what the possible corrections are. All right, number 2, if possible, have a CX team member, an additional CX team member, take separate notes. If you can have more than one CX person there in large, complicated tests, it's very helpful to have somebody else that's on your team to be able to take notes with you so that you can compare them, so that you make sure that, hey, my understanding of what I just saw and heard is the same as yours. And we can say, yep, this is exactly what happened. Take lots of pictures. When I'm doing this, I take lots of pictures. I take pictures of the screens, what's going on in each test, what transferred, what didn't transfer, what the generator settings are, what the paralleling gear settings are. Take lots and lots of pictures so that if I have to, when I need them, I can always refer back to them after the testing is completed to say, oh, this is what happened. Record all system alterations and restorations of system settings. This is very important. The paralleling gear and the emergency power supply system is designed to operate in a specific way. And when we're testing it, we're changing a lot of systems or a lot of settings in the system. And we're asking it to do different things so that we can check all of the programming and functionality of the system. It's very important that before you start testing, you make sure that hey, this is the system of operation as it's supposed to be. You record those, and you then at the very end of the testing, you make sure that everything is restored back to the original settings so that the system is going to operate as designed. A quick note about that. I did a testing one time, and we tested everything, we operated everything, and there is a bus optimization and a load shed feature on most paralleling gear. And there's usually an internal switch inside the gear that will either operate bus optimization or load shed. And they have to be in the right configuration, or what happens in the bus optimization, the generators will all turn on. And then when the system says, hey, you know what, I don't need all these generators, it will start shedding off the generators to where it only has the amount of generators it needs to supply the load that's actually connected. So it kind of like optimizes the bus and only uses or produces power and uses fuel as only as much as is needed. But that load shed feature, if it is switched on, what will happen is it works based off of how many generators are connected to the system. So if one generator is connected, it's only going to bring on priority 1 loads. If 2, it's going to bring on 2. If all the generators on, then all the loads are connected. So if you don't have those internal switches put in the right position, what can happen is the generator can kick on. You'll go into bus optimization, and the paralleling gear will start turning off generators. Well, when it starts turning off generators, all of a sudden you'll have priority 3 and priority 2 ATSs start to shed from the system and not mean to. So that has happened, and I documented that in a report, and I clearly told our clients and the maintenance staff, like, hey, when you operate it this way, make sure that you guys have a system sequence of or a method of procedure to make sure that these are always set right. Because if they just get inadvertently switched one way or the other, this is what can happen. And it was about, 12 months after I did testing on a facility, I got a call from like, hey, we did this testing and we lost some of our ATSs and we're really concerned. And, did we miss something when we were testing? And then I was able to pull, because I keep really detailed notes, I pulled out my notes, I pulled out the site visit report, and I sent it to them. And I said, hey, this is what happened. Check these settings. And then they came back and like, hey, you're right. Somebody caught in here that and they got switched when we were doing some service from a vendor, and we forgot to put these back. And so it helps to quickly be able to answer questions, and it helps to make sure that you're able to, the detailed notes or help to educate the client on what system they have and how to operate it. And lastly, provide a detailed site visit report or field observation report within 48 hours of completion, if at all possible. The sooner that you document the testing, the more accurate it's going to be, and then the more likely that everybody that reads the report is going to remember the sequence of events and of what happened, very similar to what you have just documented. So the further we get away from testing, the harder it is to remember what happened, and everybody starts to kind of not all have the same picture of what just took place. So there's a lot that goes on when we do these emergency power system tests. So it's very important. The sooner that you can document it, the better. And also too, when you're done with the emergency power system test, at the end of the day of testing, I always like to have like a debriefing meeting where everybody that took part in the test, they get together and we talk about it, and we say, hey, what did you notice? What did you see where you were at? Did you have any special comments? And then they become part of my note taking so that it is included in the report, if it's applicable. So those are some of the things that we like to do when coming down to documenting. So with that, I'm coming down to the end. The difference between something good and something great is attention to detail. So when you're doing emergency power system, supply system testing, it's detail, it's detail, it's detail. From the very beginning, when you're sitting down with the owner, through the middle, when you're working with the contractors and the vendors, all the way down to the testing and the documenting. Attention to detail is most important, and that's what's going to bring you to a successful end. With that, I appreciate everybody's time, and it looks like we have plenty of time for questions.
Great, thank you, Jason. Let's just jump right into the questions here. We have about 4 of them to cover. The first one is, you use the words template. Do you provide PFT and FPT scripts that are built project specific?
Yes. Yeah, we have PFC and FPT. So pre-functional checks and functional performance tests we have templates, but all of our templates are adjusted and modified per project, per project specification and requirements.
Okay, the next question is a 2-part one. How do you obtain the ATS settings from the project? Engineer of record do not normally have a table for this. And the second part is, how do you obtain the PSWG load KW from the project? Engineer of record do not normally have a table for this as well.
Sure. If it's an existing facility, I will talk to the maintenance staff and the facility management, and we'll actually go to each ATS. If they have an active contract with a vendor, I'll wait until the vendor is there, and then myself, the vendor, and the electrical maintenance staff will go to each ATS, and we will document what the actual settings are. That's kind of a two-purpose thing. That's going to allow me and the vendor to provide additional training to our client, which is just an added value to our clients while we work through their existing ATSs and we document the settings. If I'm not able to be there, then I will just ask. I will ask the client to go and get that information. Depending on the staff and their ability, most big hospitals have a staff that is more than capable of going and getting that information and then sending it to me. But if I can be there and be a participant in it, I try. Now on new facilities, I will ask the engineer of record for that information and for the ATS settings. And what that does is it initiates a conversation between the engineer of record and the owner. And I'll try to participate in it if I can, so that I can say I can help the owner to understand and the client to understand, hey, this is how your ATSs are going to work. You know, what kind of time delay to engine start do you want? What time delay from emergency back to normal do you want? Do you have any elevators connected to the system where you want a pre-transfer delay put in? Those kind of things, and help them to understand how the transfer switches work. Eventually, what happens is that the engineer of record will develop an ATS schedule and produce it as part of their documents on most projects that I have had those conversations on. It's been my experience that as I have worked, I've worked with one set of engineers. If I come in, I have another project with them on a totally different project, that once they have created the ATS schedule, they actually start putting it into their drawings on a regular basis. So, because it's just such a unique and good piece of information to give to the client. So the second part of the question is your connected load to the ATSs, and it's very similar to the ATS settings. So in an existing facility, I will go and I will have the facility maintenance or the facility engineer or the electrical maintenance guys give me that connected load. You know, what is the load that you see on this particular ATS when you test it monthly? And they will usually be able to provide that. And that's kind of how we get that rough number. It's an approximate number, but that's how we get that number. On new facilities, we go back to the engineer of record and we say, hey, what is your estimated KW load for this new system, for this new ATS? What do you expect the load to be? And that's our base point that we start with when we're putting that information into the paralleling gear for your load shed and load add feature.
All right. Another question here. Mechanical sequence of operations are a given. When we provide electrical system commissioning, we require an electrical sequence of operation. In most cases, this is a new concept to the electrical engineer of record. Do you require the electrical engineer of record to provide an electrical sequence of operation? How often do you see electrical sequence of operations in the project documents without first requesting it?
Very rarely do I ever. I'm starting to see it more. It's electrical sequence of operation for, say, fire alarm devices, but specifically for what we're talking about today, emergency power supply systems. It's kind of hit or miss, but I am starting to see it in the contract documents more than what I did originally. But to your question, I usually have to ask for more detail or ask for a sequence of operation because it's just not there. So it is a conversation that we do ask for. More often than not, we don't see it automatically. But in those situations, I just like to have a conversation with the engineer of record and the owner about how we can get this information.
Okay, the next question is, what % of projects do you receive a complete NFPA 110 acceptance test documentation?
So if we have emergency power in the scope of our project, that typically includes generator testing. And for us, we're going to be there when the NFPA 110 startup and load bank testing is completed. And as part of my effort in documenting that NFPA 110 adherence, now I'm not providing the NFPA 110 documentation, but the vendor is there and I'm watching them do it. And so as part of that conversation, when I'm watching them do their work, I'm like, hey, I want a copy of the NFPA 110 documentation that you're completing today. I want to see it completely documented. And by the way, I have my own. I'm documenting what you're doing. And so usually for the projects that I'm on, that is something that I see on a regular basis.
Okay, we did get a couple more questions come in, and since we have time, we can address them. Here's the next one. Does the testing you described start with individual testing of components first, then like an integrated test where power is just dropped and you see what happens?
Correct. So what we normally do is, again, if emergency power is part of our scope of work, individual components are tested. So the generator, the ATSs, any emergency power distribution breakers and things like that, we would have in our scope, and we would test and verify those individually, and then collectively building into a full emergency power supply system. Now, you mentioned a drop of normal power. That is what we call a black site test, and that is separate to the emergency power supply system test. And typically, we would do a black site test after the emergency power supply system test is completed.
Okay, the next question. Does the testing you described start with I think we just asked that one, excuse me. What is a good time to let the generators run before returning to normal power?
Well, every generator system is a little different. There is a engine or a generator cool down mode, and it can be controlled either through the ATSs or the generator control module or the paralleling gear. Depending on the system, one of those three is going to take control of the generator cool down mode. So if you have an older system that doesn't necessarily have an engine control module mounted on it, then your paralleling gear or your transfer switch is going to go through a cool down mode. Most of those programmed cool down modes I normally see between 5 and 10 minutes. Now, if you have a newer generator set that has the engine control module, that engine control module no longer does it by a timed setting. It actually does it by an internal temperature monitoring of the unit. So whenever it hits a certain temperature, it says, hey, I'm cool enough, and it just shuts the generator off.
Okay, here's the last question. Do you have someone stationed at every piece of equipment or system that should come back on during an emergency, or do you somehow pre-test that so a hospital like the size you described doesn't take 50 people to test it?
Okay, so it depends on the system. So if like one of the hospitals that we described, all of their ATSs were bypass isolation. And one of the things that we did to minimize the impact on the facility is that we bypassed the switch to normal, and we to normal power, and then we isolated the switch so that it could operate, so that we could control it and switch it remotely without impacting power. So without impacting connected load. So that's one way that we would go about it. Now, if we do need to transfer the load or make a hard transfer and say we don't have a bypass isolation transfer switch, and it's just going to flop back and forth between normal and emergency, then yeah, we would coordinate with the departments and the equipment that was going to be affected by it to minimize impact as much as we possibly could. Now, in your question, that kind of like goes between two different tests that we normally recommend. One is the emergency power supply system test, and the other is the black site test. So in the black site test, what we do is we would do a coordinated and controlled loss of normal power to the whole facility. And what we want to do is we want to see what happens to the facility during that normal loss of power. We're not necessarily testing the emergency power supply system, but a black site test, like you indicated, is going to affect all of your mechanical equipment. It's going to affect these things. How does it transition between loss of normal power and then back onto emergency power, and then from emergency power back to normal? In those instances, we would have the BAS vendor there. We would have mechanical facilities, electrical facility staff, a mechanical commissioning agent, and electrical commissioning agent. And we would actually go and visit every piece of equipment. Before we did that test, we would document all of the equipment we expected to be interrupted and impacted, and then we would actually go and physically view each piece of equipment and make sure that it made that transition in both directions correctly, so that we could give that information to our client at the end of the test to say, hey, this is how your system worked, and here's the issues that you need to get corrected.
So Jason, we did actually have at least one more question pop in here.
Okay.
Since buildings are designed so far in advance, have you had issues determining which codes apply to your test?
No. So typically, I mean, buildings are designed so far in advance, but once the construction documents are issued and you get your permitting, that permit, that's whatever date and time it was permitted under and designed under, those codes apply to that. So even if the codes change, it's still going to revert back to what the original, whatever the contract date was that it got permitted on.
Okay, and that was the last question we have. Thanks, Jason.
Oh, thank you.
I just want to close things out by thanking Jason once again and everyone else who joined us across all three organizations who are members and all of our non-members on the line. Please keep an eye out for an email with information regarding your learning units from the CX Energy app. While in the app, we're also asking all participants to evaluate this presentation. We hope to see you again next week for the next webinar in the series titled Multi-Phase Commissioning on an International Airport in Aruba, taking place May 28th at 2 p.m. this same time next week. Enjoy the rest of your day, everyone. Thank you.